Beta Pictoris is a star about 60 light-years from the Earth, and it's surrounded by this huge disk of chunks of rock and ice that we call a debris disk.
Inside that disk is a central clearing in the larger planetesimals, and inside that central clearing is a planet more massive than any in our solar system.
We see the Beta Pictoris debris disk edge on, so we just see the thin strip of it from the edge. But there's an interesting feature that we can see just from that edge-on view.
When we view Beta Pictoris at longer wavelengths, people claim that there's a warp in the center of the disk. At shorter wavelengths, it looks more like an X. And we haven't really understood until now how those patterns were related. But Erika Nesvold and I invented a new kind of model which shows us the connection between those patterns.
Our model is called SMAC, which stands for the Superparticle Method Algorithm for Collisions in Kuiper Belts. We're creating a virtual solar system inside the computer, and by tweaking the parameters of the system, we can control what this virtual debris disk looks like. Then we can compare our results to the actual images of the debris disk we see and understand how the planet could be creating these different shapes in the disk.
The model painted one picture of Beta Pictoris that showed us the origin of the X pattern, the origin of the warp, and also a bunch of other details about the system.
Our simulation is the first model that can capture the 3D structure of the disk, as well as the collisions that are occurring between the planetesimals in the disk. And our simulation is the first model that can explain these multiple different features that we observe when we look at the Beta Pictoris disk. So if we look at our simulation results edge-on, the same way that we see the real Beta Pictoris disk, then we see this warp structure that's created because the planet is orbiting tilted with respect to the disk. If we look at our simulation results face-on, which is a way we can't see the real disk, then these face-on simulation shows this spiral density structure of the planetesimals. And this spiral is created because the planet's on an eccentric orbit. It's not a perfect circle, it's an ellipse. When the spiral created by the eccentricity of the planet intersects with that vertical wave from the inclination of the planet, the collisions are enhanced in some places and damped out in others, which creates this clumpy collision structure.
If you look at our model in cross-section, you can see the crests and troughs of the wave where the collisions are enhanced. Like an ocean wave, in front of the wave it's calm, but then the crest comes along and lifts the planetesimals out of the plane. And then there's a trough, and then the wave starts wrapping around tighter and tighter. And then it's almost like foam on the backside of the wave. The planetesimals get all stirred up and start colliding with one another and breaking into dust. We've learned so much about Beta Pictoris over the years, but all the little pieces of evidence didn't seem to fit together before. This model tied together in a nice, neat package the story of Beta Pictoris and its planet.
In the future, we'll be able to use our SMAC models to study other debris disk systems and use our observations of those disks to predict the presence of exoplanets that we otherwise wouldn't be able to detect.